Hello, everyone. Thank you for joining us today. My name is Chris Harding. I am a solutions engineer here at Epsagon. And today we'll be giving a talk on the golden signals for SRE in microservices. Before I get started, I thought it would be helpful to provide context, a little bit about me, a little bit about Epsagon. As I mentioned, I am in the solutions engineering team here at Epsagon. Epsagon is a trace-centric observability platform, primarily built and tailored to modern microservice environments. And so in layman's terms, what that means is we provide end-to-end observability into your microservice applications. Myself, from a background perspective, I spent the beginning part of my career primarily in business development, most recently in the fintech space, working at a company acquired by NASDAQ. More recently, I spent a number of years as a full-time software engineer, first at a large Fortune 100 financial services company, and then at an early stage startup. And now I'm part of the solutions team here at Epsagon. Today we'll be broadcasting right from our New York headquarters. All right, let's provide a little bit of context. Let's provide a little bit of level setting as to what we'll be discussing today. That's going to cover four major topics. The first of which are the four golden signals of site reliability. Every application, every tech stack is going to be different as it relates to what the most quote unquote important signals are for you to track to understand the health of your application. But luckily for us, there are sort of four golden signals that have been identified. And so we'll talk a little bit about what those are. I then want to talk about the rise of microservices, specifically how the transition to microservices, from your traditional monolithic applications increases complexity in being able to monitor and understand your applications. We'll look at some of the existing monitoring tools against that backdrop. We'll then transition to talking about observability and distributed tracing. When we talk about microservices and observability here at Epsagon, observability to us has three major pillars: metrics, logs, and traces. Metrics and logs, as we'll see, have been around forever. But traces are relatively new. And so let's take a look at what traces are and what they mean and how they fit into that current landscape. We'll close off our presentation by tying everything together, by taking a look at how a good observability tool can really be leveraged to get the deep sort of insights that you would need into these four golden signals. All right, great. So let's start by looking at these four golden signals. As I mentioned earlier, depending on the services and applications that a company offers, whether they be e-commerce stores or video streaming services, the metrics that you're going to want to monitor to understand the health are going to be different. You need to check what metrics are relevant to your customers and focus on these. But luckily for us, SRE practitioners have found four metrics that are crucial for any company to monitor. These four golden signals are not only relevant metrics to measure, but if resources are tight or if you're looking for somewhere to start, these should really be the focus for you. And these four are latency, traffic, errors, and saturation. And so let's look at each one of these in turn. First, we have latency, and latency refers to essentially how long a process takes to complete. In terms of the UI, it could be the delay from when someone clicks a load button to the time that data is, for example, finally displayed. There are a host of different things that can ultimately have an impact on what that latency looks like. Things like what type of data is it? Is it something that has to be calculated on demand? Is it something that's inherently big, like a video file? Where is the data stored? Is it on the client's device already? Is the data somewhere in a data center across the globe? Is it in an SQL database or a key value store? All of those are important. And how fast are the data sources ultimately in delivering data? Are we talking milliseconds, seconds, or even sometimes we could be talking minutes? And so all of those things are just a few of the important aspects that are ultimately going to impact what that latency looks like. A click on a button, as I'm sure everyone here can appreciate, isn't just a click. It's an event that travels from the tip of a user's finger all the way around the world to a server and then back to that user's eyes. The job of an SRE team is to measure that latency and also to improve it when it gets too high. Depending on the scope of the SRE, this can include things like network latency, database latency, or even the time it takes to render the data onto a client. To find a bottleneck in a specific action is not a trivial problem, and guessing can lead to wrong assumptions that could cost a lot of money. We'll discuss how to handle some of these challenges as we progress through our session. Moving forward, traffic, as opposed to latency, is the demand on your system. This can be a different metric depending on your service, but for example, might include things like HTTP requests per second that are being sent to your website or your API. This metric gives a rough overview of quote unquote how much is happening for a given period of time, how many requests are hitting your API as an example. It helps you understand things like, are more users active in the morning or the evening? Are they more active on the weekend or weekdays? And how do things like the season, summer and winter, impact that overall traffic? A sudden change in traffic can mean a lot of things, both good or bad. If your traffic goes to zero after deploying a new version, chances are pretty good that something went wrong. If your traffic suddenly spikes, it could mean that you've had a hit marketing campaign. It's worked out really well, and that's generating a lot of traffic through to your website. If you see an unusually high traffic pattern on a protected part of your website, it could indicate to you that there may be some security breach or security issues at hand. Overall, traffic gives you a sense of what part of your service is in high demand and which parts are perhaps not as interesting to users. The third golden signal is around errors, and of course, monitoring errors per a given period of time helps you to identify essentially how well your system works, or at least how well it's being used. There are, of course, many different types of errors, each of which can be very context dependent to your application, but some examples would be if a service is down, a bug crashes your server, and all the requests will fail until that server gets restarted. Or maybe it's an issue where you have a service that's overloaded. A service can only handle so many requests, and so everything above that threshold will ultimately be counted as an error. Or maybe it's an issue with clients using those services incorrectly. If a client sends invalid requests, it could be an issue with your documentation, it could be an issue with versioning, or maybe it's just an end user issue. In this case, your services are okay, but your customers still aren't getting what they want, and that's very important to know. The last of our four golden signals is around saturation. When we're talking about saturation, what that measures is the usage of your system relative to its maximum capacity. And that might mean on the memory side, on the CPU side, or even things like I/O throughput. This metric, saturation, can help you determine the optimal provisioning of your infrastructure. You don't want to pay for resources that aren't being used, but you also don't want to have a system that is close to its maximum saturation or threshold at all time, as the next traffic spike could ultimately lead to an overload. In a well-defined system, overloads are handled gracefully, but this is not always the case, which can lead to a set of cascading errors. So now that we understand those four golden signals, let's take a look at sort of the modern microservice-based environments, and let's take a look at that modern development landscape. Day by day, the technical world we work within is becoming increasingly complex and distributed. One of the reasons for that is because, as research suggests, somewhere in the range of 90% of enterprises are adopting microservices as their default architecture. We'll call that the rise of microservices in the cloud. We can see what that looks like as a visual representation here. That transition starts usually with host-based monoliths, moves to host-based distributed, and ultimately gets to a place where it's highly abstract in host and also highly distributed. I suspect many of you listening to this session right now are yourselves on some stage of this journey. And so it's great to have this discussion now and understand how does this rise of microservices impact those four golden signals. The rise of microservices has obviously happened for a reason. It brings with it many benefits, particularly as it comes to developer velocity. You can have one team working on a very specific microservice. They'll be able to update that when they're ready without having to impact all of the other services in that stack. But it also brings with it drawbacks, particularly when it comes to monitoring tools we once relied on, which are now ineffective at providing the rich troubleshooting that data engineers, DevOps professionals, and SREs need to be efficient within their job. Today, services are traversing a mixture of microservices and serverless components, running in container ecosystems or orchestration platforms like Kubernetes, and these services can touch dozens to thousands of entities mixed with external APIs and managed services as well. How can you properly monitor your application's health and look into those 4 golden signals in this new world? Before we get to that, let's take a look at some of the traditional solutions that are out there when it comes to understanding the health of your application. And the primary 2 of those are, as we would say, host-based monitoring, as well as logging. We'll first touch on this old school monitoring. Traditional monitoring solutions come at the expense of, as I'm sure everyone here can appreciate, high resource utilization, and that's all due to the heavy instrumentation that's ultimately involved in getting those agents up and running. They also have severe limitations on what they can actually collect. When we're talking about old school monitoring platforms, we're primarily talking about the ability to collect host data and metrics. And so those solutions are going to be metric-driven solutions only. Metrics do a great job, of course, of telling us that something is broken, telling us what's going on within our application, but they don't necessarily tell us where or why something is broken. And when we're moving to microservices and we're talking about tens, hundreds, or thousands of different services, that where and that why becomes increasingly crucial and increasingly difficult to understand. Often in conjunction with these old school monitoring tools are what we would call old school logging tools. I'm not going to sit here, I mean, I spent many years as a software engineer at a Fortune 100 company, having to troubleshoot issues and dig through logs myself. I'm not going to sit here and tell you they aren't needed, or that troubleshooting with them is a completely futile endeavor. Of course, logs can be an incredibly powerful tool within your troubleshooting arsenal, but they come with an added cost, and that cost is both monetary and operational in nature. Logs oftentimes require yet another agent to be installed and managed in your environment. Further, they can be incredibly expensive when accounting for things like data egress costs in order to get logs out of a cloud environment and into one of these log aggregation platforms. You also have to hope that when your developers are actually writing their code, they're accounting for what sort of data should be logged out, what sort of data is ultimately going to be helpful for our troubleshooting. And of course, they're human, and so that's going to give you a large potential for spotty troubleshooting data or inconsistency across teams. Or conversely, you might have too much data causing paralysis by overanalysis. These are all very common issues that we see, and I've certainly felt myself working in this space. Further than that, logs also lack key context to critical metrics, events, and traces, requiring engineers to manually search and scroll through millions of lines to hopefully spot the why and the where of that failure. It's not uncommon to spend hours scrolling through logs, searching for potential exceptions, hoping you'll be able to spot that needle in the haystack. And so these traditional tools, your traditional monitoring, your traditional troubleshooting, they leave lots of gaps. They leave a lot to be desired when we're talking about these modern microservice environments. When we're talking about these new and highly complex environments, there will be significant challenges. And so instead of leveraging a traditional APM solution, which are fantastic for classic client-server applications, we now have thousands of services with intermingling databases, caches, and more that we really have to consider when it comes to observability. So here's some of the issues that we see. And when it comes to monitoring and logging, they're great, they're very helpful, but something is still missing. How do we correlate between those metrics and logs? How do we correlate between data in different services? How can we have a single pane of glass, as it were, not only when we want to troubleshoot issues as they're occurring, but also to find perhaps inefficiencies and quickly optimize our tech stack as we're growing out and building new services. Context is always key with any type of data point. So how can we ensure that we're correlating metrics and logs, and how do we further correlate that data between our distributed services within your environment? Surely there must be a better way. And this brings us to that third pillar that I mentioned, which is distributed tracing. We really consider distributed tracing to be a more modern APM solution, a more modern application performance monitoring tool. What is a trace at a very high level? A trace tells the story of a request or data as it propagates through the distributed system. Many of you have probably heard a lot recently about tracing. Many vendors offer some form of distributed tracing, and many things like service meshes are now built with that support natively. There are also dozens of open source solutions, some of which are actually born out of huge enterprises. But where did it begin and why? Distributed tracing was born out of Google a little over a decade ago, really to allow their engineers to trace the specific path a request is making through all of the services that Google hosted. In effect, distributed tracing allowed them to shine a light on that needle in the haystack that logging and metrics alone can very easily miss. Just because your application is made up of 15,000 services, of course that doesn't mean that every request will flow through all 15,000 services in a standard and specific way. In almost every case, a request will only touch a fraction of those services. And so distributed tracing was very much put in place to allow you to follow that business transaction from end to end. And beyond that can be pretty helpful once in place to understand things like how much time is being spent in each service of a given request. Tying those traces together with metrics and logs is what gets us back to what we call those three pillars of observability. It's only through the combination of these three things that you can truly have understanding of these complex environments. And that's because metrics tell us what, logs tell us why, but traces, importantly, tell us where. All right, so now let's take a look at troubleshooting the right way. And when I say the right way, what we mean is really how would you troubleshoot using one of these observability tools? How would you troubleshoot when you have a trace-centric system in place to really allow you to understand what's going on under the hood? All right, here's an example of what that correlation looks like and what that trace looks like. The trace, as you can see, allows us to look at each stage of our request and understand what's going on, and allow us to understand what's going on and correlate what's going on to things like the stack trace, to things like the logs that are being collected. At Epsagon, we believe in lightweight, easy to implement tracing right out of the box, with visualization that, as I mentioned, provide context between traces, metrics, and logs all in one unified view. Whether that trace begins from an S3 file drop that triggers a serverless Lambda function, or the usual web request that you want to see the end-to-end picture of exactly which services that request hit, including all of those services as well as any of those middleware components as well. Additionally, when an issue arises, we want to provide our users with flexibility of accessing the full payload for each request. If the user of your platform opens a ticket, you'd be able to search for any sort of payload field, their email, user ID, or some ID to tie back to that user and be able to say, okay, here are all of the traces in our application associated with that specific user. And of course, equally important for anyone who's understanding and working with production level systems is the ability to have this live, what we call tail tracing. That is, the most recent traces keep propagating in the system, and it allows for rapid remediation. For example, what if we added a new service into the mix, or there's a new large deployment? We want to provide this live tail experience to allow end users to quickly and easily see trace data as it starts flowing in. Smart alerting strategies based upon thresholds or specific errors can of course alleviate this need in most cases. However, if you need to quickly validate that an issue has been remediated, this can be a tremendously helpful mechanism. Of course, we can further cut down on the noise from other services or applications and filter this sort of trace search view down to a specific entity, ensuring that we're only showing traces based on specific criteria. Maybe that's only showing traces that are Dynamo database uploads, or only showing traces where a certain latency threshold has been exceeded. A lot of flexibility in how you can use these traces to troubleshoot and remediate on the fly. Engineers also expect actionable data within these complex visualizations and maps, and so that's something we want to provide in the Epsagon platform. As we zoom in or filter on specific components within this service map, you'll have the ability to start seeing important metrics, things like, for instance, the latency between any two given components, as well as areas where maybe a specific threshold has been crossed. We see this red arrow, and that's because we have a very high error rate for this specific service. We know visually that this is something we're having high errors for, and ultimately is something that we're going to want to look into and start looking at those traces to understand what's going on. So where does that leave us? We've defined the 4 golden signals: latency, traffic, errors, and saturation. We've talked about how the rise of microservice changes the monitoring of those signals, but what might that really look like? What would an observability tool with this sort of insight give you access and ability to visualize and see? Let's start with latency. Right? In a highly complex distributed environments, we want to be able to pinpoint where in our services time is ultimately being spent, where that latency happens. This is equally critical in cloud transformations and for continued service excellence. If 40% of users will leave a site or application that has a latency of 3 seconds or greater, it becomes absolutely crucial in saving revenue and ensuring a satisfactory end user experience. Service maps can be a one-stop shop for pinpointing where time is most often being spent within these large-scale applications, and that helps you as an engineer determine where to be spending your time on to ultimately root out some of these inefficiencies. This service map we see here, generated automatically in Epsagon, gives you that understanding of where your time is being spent, both on synchronous and asynchronous calls. A tracing solution should also pinpoint where in the code time is being spent. And we can see a sort of a waterfall visualization of that trace we just looked at. Is a significant portion of time being spent waiting for an external API to respond? Or perhaps we have inefficient database calls being made that need refactoring. These waterfall visualizations make it easy and can also provide you with the rich context of the header metadata to begin doing that real-time troubleshooting. So being able to click in to one of our GET requests and seeing the full payload, again, provides that real quick and efficient way to get into and start understanding what's happening in your application from a latency point of view. What about traffic? Similarly, as we saw with latency, we need to not only look at the traffic of our application holistically, which is of course important, but we also have to look at it in the context of each service and component. Let's say we have, as an example, a payment service that handles all of our processing, and that traffic drops to 0. It's a huge problem, right? I mean, even if the traffic in every other service is at 100%, it's important to know that that payment service has failed. And so an observability tool, a good observability tool, is going to provide you with the flexibility to slice and dice these data in any number of ways. And we'll see a couple of examples here in the slide, right? We may want to look at, for example, the amount of traffic based on application. We have multiple applications in Epsagon. One is a store, one is a processing pipeline. What does that total traffic look like? Or we might want to see, what the traffic looks like at a resource type level, right? How many traffic is going through Lambdas? What's the traffic through all of our Dynamo databases? Really, the ability to slice and dice in any way that's specific to your use case is what a good observability platform should do, and ultimately what we try to provide here at Epsagon. On the third of the golden signals, which are errors, it's going to be very similar. Not all errors, as we mentioned earlier, are the same. An error that is critical in service A might be something you can completely ignore in service B. And so again, when it comes to really understanding the error state of your application, you need to be able to look at it from a number of different viewpoints. Maybe that's breaking it out by error code, as an example we see here. A user that's being rate limited is, of course, important information, but it's not as critical as seeing a ton of 500 spike all at once, which tells you that it's not one specific user hitting the service too much. The service has essentially failed. Not every error is the same, and so of course you want to be able to split them out. Further, we may want to be able to look at errors not based necessarily off the error code itself, but based off of the type of exception that's being generated. And so we're able to pull this information out of our traces to visualize and show what are the errors and how does that break out by type. There are any number of ways you might want to visualize, track, and understand errors throughout your system. And it's the job of a good observability tool to allow you to do just that. All right, the last part that we'll touch on is as it relates to saturation. So of course, when we talk about a modern microservice environment, and often in many cases, the infrastructure itself is almost being abstracted away and handled entirely by the cloud provider. Think of things like AWS Fargate or AWS Lambda, where you don't actually touch the servers. All of that is managed at AWS. Or maybe it's something where it's being handled by Kubernetes, which is your container orchestration platform. And of course, Kubernetes would be then in charge of keeping enough resources spun up based on some predefined rule set. And so a good observability tool will provide you deep insights into what is happening at the resource level for something like your Kubernetes implementation. So you'll want to be able to see, as we do here on our slide, information at the cluster, nodes, pods, containers, as well as deployment level. You'll want to understand what your resource usage level is at each. Things like how much memory your CPU, your cluster is using, or how much network traffic or disk read-write is hitting each node. And you'll want to have full context as well into those traces. So for example, we see a cluster that's having issues. Maybe we want to see all of the traces associated with that cluster. A good observability tool will allow you to do that. And it will provide that out of the box. Similarly, we want to have full context between things like our containers and the container logs. That's another correlation that a good tool should handle for you out of the box. All right, lastly, and sort of comparing this to something like Kubernetes, it's a very similar story. When we're talking about containers hosted on something like, let's say, an ECS service or otherwise, you're again going to want to and need to have that full insight into what is going on at the resource level for your clusters, services, instances, and tasks. And of course, you'll want to be able to dig into the traces and logs associated with each to really get a full insight into what's going on. And so just like with Kubernetes, a good observability tool will provide this level of insight and correlation for you out of the box. Moving forward, in a world where, as we can see, applications are becoming increasingly complex, it's very important to have the tools needed to evolve in that same direction. And when it comes to understanding the four golden signals and understanding them on a service by service or resource by resource basis, true observability is only going to continue to grow in importance, and we look forward to being there to provide the tools to help our users understand exactly what's going on within those microservice environments. Thank you. Thank you so much for taking the time to join us and listen to this little presentation today. If you have any questions, we'll be doing a QA shortly here, but if you can't attend or something pops into your head a little bit later, feel free to reach out to me. I'm chris@epsagon.com. You can also learn about some of our special offers by visiting epsagon.com/giveaways. All right, excellent. So now we will open up the floor to any Q&A there might be. Thank you again, everyone, for coming. Really appreciate your time.